Welcome to ScienceCover.com. In this session, we will investigate weight. The aims of the session are to know the difference between a weight and a mass, to investigate the behavior of falling objects, and to know why a falling object has a terminal velocity. Before we begin, pause the video and attempt the do now task. Let's check our answers. Number 1. A car of mass 400 kilograms accelerates at 50 meters per second squared. What force is produced by the engine? Well, force is mass multiplied by acceleration, so we have 400 multiplied by 50. This is 20,000 newtons. A cyclist of mass 80 kilograms produces a 20 newton force on his bike. What is the acceleration of the cyclist? The acceleration is force divided by mass, so that's 20 divided by 80, which is 0.25 meters per second squared. A rocket fires its thrusters, producing a force of 10,000 newtons and accelerates at 3 meters per second squared. What is the mass of the rocket? So mass is force divided by acceleration. So that's 10,000 divided by 3, which is 3,333 kilograms. A boy of mass 20 kilograms pushes a boy of mass 30 kilograms with a force of 60 newtons. What is the acceleration of boy B? Well, the acceleration is the force divided by the mass. He has been pushed with a force of 60 newtons and he has a mass of 30 kilograms. So 60 divided by 30 is 2 meters per second squared. What will the size of the reaction force be on boy A? Well, the reaction force should be the same size, so that's 60 newtons. And what will the acceleration of boy A be? So acceleration is force divided by mass. So 60 is the size of the force, but this time we're dividing by boy A's mass, which is 20 kilograms. So 60 divided by 20 is 3 meters per second squared. Now let's look at the difference between weight and mass. A mass is a measure of how much material an object is made from. We measure mass in kilograms, and we can do this using a scale or a balance. Weight is a force that pulls an object down to a ground. We measure weight in newtons, and we would use a Newton meter. Mass and weight are related. An object with a larger mass will produce a larger weight. This equation shows how they are related. The weight in newtons is equal to the mass in kilograms multiplied by the acceleration due to gravity, or g. Now, g is a constant, a value of 9.8 meters per second squared here on the Earth. So weight is equal to mass multiplied by 9.8. Let's have a look at how we can use this equation. What is the weight of an elephant if its mass is 500 kilograms? Well, we know that the weight is mass times by the acceleration due to gravity. So this is 500 times by 9.8. If we put that on a calculator, we find that it's 4,900. And since weight is a force, we measure it in newtons. We can rearrange the equation using an equation triangle. We place weight on the top of the triangle and mass and gravity at the bottom of the triangle. So to find the weight, we cover up weight and its mass multiplied by gravity. To find the mass, we can cover up mass and it's the weight divided by gravity. But if we have a question asking us to find the gravitational field strength, perhaps set on a different planet or moon, then we can take the weight of the object and divide it by the mass. What is the mass of a train that has a weight of 400 newtons? Well, mass is the weight divided by the acceleration due to gravity. So this is 400 newtons divided by 9.8. And that equals 40.82 kilograms. Now let's look at an example of a situation not set on Earth, where g is not a value of 9.8. An astronaut of mass 80 kilograms is stood on an asteroid where his weight is 240 newtons. What is the gravitational acceleration of the asteroid? So we want to find g in this question, so that is the weight divided by the mass. So that's 240 divided by 80. Now if you put that on a calculator, we find that it's 3 meters per second squared. So the gravitational field of this asteroid is much weaker than the gravitational field of the Earth. Pause the video now and complete task 1. Let's check our answers to task 1. Calculate the weight for each of the following. Assume g to be 9.8 meters per second squared. A monkey of mass 30 kilograms will have a weight of 294 newtons. A dog of mass 20 kilograms will have a weight of 196 newtons. A car of mass 200 kilograms will have a weight of 1,960 newtons. And a rocket of mass 20,000 kilograms will have a weight of 196,000 newtons. Calculate the mass of a grape that has a weight of 0.1 newtons. This will be 0.01 kilograms. A tank that has a weight of 40,000 newtons will have a mass of 4,081 kilograms. A fish that has a weight of 800 newtons will have a mass of 81.6 kilograms. And a satellite with a weight of 300 newtons will have a mass of 30.6 kilograms. On Mars, a 70 kilogram astronaut has a weight of 260 newtons. What is the strength of the gravitational field on Mars? So G is equal to the weight divided by the mass. This is 260 divided by 70, which is equal to 3.71 meters per second squared. How does this compare with the field on the Earth? It's almost 3 times weaker. How would this affect the person's mobility? A person could jump 3 times higher, throw objects 3 times further, but the weak gravity will eventually lead to muscles on the body working less and becoming weaker. Now let's investigate falling objects. The moment an object is released, it has no motion or momentum. But the force of weight is acting on the object, and this force causes it to accelerate. We can calculate the acceleration using the force and the mass. So the acceleration is the force divided by the mass. So for this baseball, the force is the weight pulling it down, 1.47, and we divide this by the mass of 0.15 kilograms. This tells us that this baseball will accelerate at 9.8 meters per second towards the ground. If you select a larger object, like this bowling ball, which has a mass of 1.5 kilograms, we can use the same equation to calculate the acceleration for the bowling ball. So the force is the weight pulling it towards the ground, 14.7, divided by its mass of 1.5, and this also equals 9.8 meters per second squared. So the acceleration caused by gravity is always the same, no matter what the weight of the object. That means that this bowling ball and this baseball will both accelerate at the same rate. Why do we not see all objects fall at the same rate on the Earth? According to the science, dropping a feather and a hammer both should accelerate at 9.8 meters per second and hit the ground at the same time. But were we to perform this experiment, the hammer would clearly hit the ground first. This is because that here on Earth we have air. The air is in front of the moving objects and slowing down their movement. We call this air resistance. The feather, being lighter, is slowed down more easily by the air than the hammer. We calculated the acceleration of the baseball using the equation F equals ma. Force is equal to mass times acceleration. And we ended up with an acceleration of 9.8 meters per second, which we call g. So we can substitute this into the equation so that F is equal to m times g. We also know that weight was the force pulling the ball to the ground. So we can substitute this into the equation, and now we have W equals m times g. So the equation weight equals mass times gravity is just another way of writing force equals mass times acceleration. Pause the video now and complete task 2. Let's check the answers to task 2. What is the initial speed of a falling object? 0 meters per second. How does the force of gravity of a falling object change its speed? It accelerates the object towards the ground. What is the acceleration caused by the Earth's gravity in meters per second squared? It's 9.8 meters per second squared. Why does gravity produce the same size acceleration on a heavier object and a lighter object, even when the heavier object has a larger gravitational force acting upon it? This is because the weight of the object increases, the force pulling it towards the ground increases, but it also becomes more difficult to accelerate with a force. The weight of an object is inversely proportional to the acceleration its weight will produce. Doubling an object's weight will double the force pulling it down, but the object is twice as hard to move, so acceleration stays at the same rate. What additional force causes us to observe objects falling at different speeds here on the Earth? That's air resistance. Now let's look at terminal velocity. As an object falls, it accelerates due to its weight. This baseball has a weight of 1.47 newtons pulling it towards the ground. Once it starts to move, air particles in its path cause drag. As the ball's speed increases, the size of the drag increases. Eventually, the drag force is the same size as the weight. At this point, the object stops speeding up and falls at a constant speed. We call this speed terminal velocity. Terminal velocity is the maximum velocity achieved by a falling object. It occurs when the drag force is equal to the weight. The object will then be falling at a constant speed. We can see on this graph that when the weight is larger than the drag, the falling object accelerates. However, as the object speeds up, the drag force becomes larger. When the drag is equal to the weight, the object falls at a constant speed. Pause the video now and complete task 3. Let's check our answers to task 3. What is the terminal velocity? This is when the drag force acting on a falling object is equal to the weight of the force. This results in no net force. This creates no acceleration, so the object travels at a constant speed. This graph shows the velocity of a skydiver plotted against time. Which point on the graph represents the point at which A, the skydiver jumps from the plane? That's represented by A. The weight is larger than the drag. That's represented by B. The skydiver reaches terminal velocity. That's represented by D. A ball is dropped from the top of a building. Explain how the forces acting on the ball will affect the speed as it falls. At the moment the ball is dropped, there is only a force acting down. This accelerates the ball downwards. In the early stages, the ball falling has a weight that is larger than the drag. This creates acceleration. As the ball accelerates, drag increases. Eventually, drag will be equal to the weight. At this point, there is no net force, and the ball travels at a constant speed. We call this terminal velocity.